Hello Math 3A and welcome to problem set number 2, some examples that I'm going to do. Something like number 1A, 1B. So this is take the derivative, set it equal to 0, and then solve for x. Here's one with trigonometry. We've got one with the e function and the product rule. And then I'm also going to do one like number 4, where you find the equation of a tangent line. Just as a quick reminder, you can also look through the podcast problems, which you do need to do these anyway for homework. And you could just go to this one right here, for example, finding the equation of a tangent line, the height of a baseball. So if you look through these podcast problems, and then you can go to my YouTube channel and watch the videos on those. So some of these are very similar to what you find on the problem set. And now to the examples that I made up. The first one is similar to number 1, part A. Where is the derivative equal to 0? And of course, I am going to take the derivative using the power rule, not using the limits anymore. Now that we've got the power rule, I could go ahead and use that. So the derivative here will be 3x squared. The derivative for this one is going to be plus 6x. The derivative of negative 45x is negative 45. And then derivative of negative 5 is 0. So when you set this equal to 0, when you have an x squared and an x and a number, then most of the time you need to use the quadratic formula. So you could use the quadratic formula and find out what x equals. Sometimes it could be factored. I do notice that this one has a 3 and a 3, and I could factor out a 3, or I could even divide both sides by 3. That's just going to make the numbers a little bit smaller when I do the quadratic formula, but it'll still give me the same result. So that's going to be 0 equals an x squared plus a 2x minus a 15. And then just real quick, do the quadratic formula. So that's going to be negative 2 plus or minus the square root of 2 squared minus 4 times a times c. Then just extend my little square root. And then it's divided by 2 times a. And then how much is in the square root? Well, a negative times negative will be positive, and 4 times 15 is 60, and this is another 4. So that's going to be the square root of 64, which happens to be 8. If not, so if this said the square root of 65, then from that point on you should use decimals. So don't give an answer with the square root of 65 in it, but give the decimal answer. Okay, so this is going to be negative 2 plus or minus an 8 divided by 2. So that's going to give us x equals, let's see, a negative 2 and a positive 8. That will be 6 divided by 2 is 3. And then a negative 2 and a negative 8 is negative 10 divided by 2 is... So keep track of the negatives. Negative 2 and negative 8 is negative 10. Divided by 2 is negative 5. So that should be where the derivative equals 0. And now I want to graph it and see if I got it right. So here I am showing all my work. I'm actually done right there, but I want to graph it to see if this is correct. So graph the original function. Whenever you're checking your answer, always graph the original, not the derivative. All right, then let's see what's going on. So take a look at the graph. And the graph seems that it's so big that most of it's off the screen. So what I do is I say, okay, if I plug in 3, trace and plug in 3, that says negative 86. And if I plug in the negative 5, that says 170. So most likely if I change the window and have the y values go from negative 200 to 200, then I should be able to see what's going on. So right up there, when it reaches that maximum, the derivative equals 0 right there. And right here, when it reaches this minimum, the derivative equals 0. So if I check the 3, trace, and put 3, that should be when it's at the bottom or the minimum. And then also I can check the -5, and that should be when it's at the top right there or the maximum value. So those answers look correct. Yet another way you can check your answer is go to second calculate. And if you go to number 6, that's the derivative. So find out the derivative when x equals 3. And then right there, it says the derivative does equal 0. Okay, so I've thoroughly checked. This is correct. Next up, what about something that has some trigonometry? Y equals secant the square root of x. On the interval from 0 to 15. And yes, I did make up this problem myself. So sometimes I do the graphing at the beginning, sometimes at the end. Sometimes I trust my answer completely and I don't even graph it because I feel confident. So with this one, my calculator does not have a secant button. So instead I have to use the trig identity that secant equals 1 divided by cosine. And then put the square root of x and get out of the square root and close the paren. Then change the window, go from 0 to 15. And I'm not exactly sure what to put for y, so I'll just put -10 to 10. All right, and looking at this, so in here, the function is always going up. So the derivative does not equal 0 over here where my pen is. Because for this, since it's going up, the derivative would be positive. Because derivative is talking about slope, so this has positive slope. Here, it goes up until right about here, and then it starts going down. So it should be right about here where the derivative equals 0. And this is 15, 14, 13, 12, maybe at around 10 approximately, x equals 10. All right, let's find out. So first of all, the derivative of secant is secant times tangent. So the derivative of secant for the square root of x will be secant the square root of x times tangent the square root of x. So that takes care of the derivative of secant. Now, according to the chain rule, I need to take the derivative of the square root of x. And in the lecture videos, I said, ones like this, it's nice to just know so you don't have to rewrite this as x to the 1/2 and take the derivative. So the derivative for the square root of x is 1 over 2 times the square root of x. Now, the idea is, when does the derivative equal 0? I forgot to write that down. When does y prime equal 0? So if you rewrite secant as 1 over cosine, and I'm just going to leave tangent as itself. So basically I have a fraction. And when does a fraction equal 0? Only if the top equals 0. So this one does not equal 0. Also this one, the only way that a fraction could equal 0 is if the top equals 0. So this one also does not equal 0. The only one that can is the tangent. So when does tangent, the square root of x, equal 0? So if you think about the tangent function from trigonometry, it looks like this. And this is an asymptote over here at pi over 2. So when it equals 0, is x equals 0. And then if you take this square root of x and put it equal to 0, that means x equals 0. But in the directions, it said do not include 0. Find a number between 0 and 15, not including 0, not including 15, but between. So just go back over here to the basic graph of tangent from trigonometry. So tangent has asymptotes at negative pi over 2 and pi over 2. That means that this is a length of pi. So if you need another copy of it, then you have to move over by pi. So this is another place where tangent equals 0, and that's when the argument is pi. So you then have to say whatever's in the parentheses right here, when that little guy equals pi, that's when tangent of the square root of x will equal 0. Last thing, square both sides. X is equal to pi squared. And I feel so confident in my answer, I'm going to go ahead and circle it now and then check. So it was right about here where the graph went up. It reaches a height, its highest point right here, and then it's going to be going down. And then where is that point right there? That should be pi squared. So trace and put pi squared, and that should be a point right about there. Perfect. So that's where the derivative equals 0. All right, let's see what's next. So this is like number 2 on the problem set, where we have not only trigonometry, also the e function. Also, to find the derivative, we need to use the product rule. So the product rule is going to say take the derivative of the e function, which is the e function. And then the chain rule will say take the derivative of negative x, which is a negative 1. And then leave sign alone. So we're halfway done with the product rule. The other half says now leave the e function alone and take the derivative of sine, which is cosine. And then set it equal to 0. Notice that the e function shows up in both of these, so we could actually factor out the e function. This will leave behind negative sine, and then plus cosine. And then we need to set this equal to 0 and find out the solutions between 0 and pi. So the e function never equals 0, so this one has no solutions. Then set this one equal to 0. And we have a trig equation to solve. So when solving a trig equation, one of the important principles is that you get the same trig function throughout. So it could either say sine and another sine, or cosine and another cosine, or tangent and another tangent, but they should all be the same trig function. So to get that done, what I'm going to do is first of all add the sine to the other side. So it says cosine of x equals sine of x. And then I could divide both sides by cosine, which basically eliminates the cosine on the left side, moves it to the right side. But what's even better than that is this will just be a 1. Sine over cosine is tangent. So I got it to be just one trig function. And then when does tangent equal 1? Yes, you're right. That is pi over 4. So you can take tangent inverse. First of all, make sure it's in radians. Radians, radians. Take tangent inverse of 1, and that looks like pi over 4. If you're not sure, you can say divide that by pi and go to math and tell me what fraction that is. So that means that it's 1/4 of pi. So x equals pi over 4. And now let's see, is there going to be more than one answer? So graph the original function, the e to the negative x times the sine of x. Look at it on the window from 0 to pi. And sine ranges between -1 and 1, so I'm going to try that. So right there, the derivative would equal 0. And perhaps right there, but that's the pi, so I already know that that's pi. So that one right there should be the pi over 4 when it got to the top of this little hill right here. So trace and then find out pi divided by 4. That looks correct. And I could even check it another way. Second, calculate what's the derivative when I put pi divided by 4. And it says the derivative equals 0. So then I can even be a little bit fancier and draw a picture. So just draw this picture. It basically went like this. And then this was the pi. And this was the pi over 4. And the next part is, where's the derivative positive? Well, derivative is talking about slope of a tangent line. So it's basically saying, when is slope positive? Well, slope is positive when it's going up. So basically this part right here, as it's going up, well, that red's not showing up very well, but this is the part where slope of the tangent line is positive. So that would be between 0 and pi over 4. So between 0 and pi over 4, that's where the slope is positive, or the derivative is positive. So this is my answer, but I do need to write it as an interval. Now, because when we got the pi over 4, the derivative equals 0, that's when it gets to the top. When it gets to the top, it's no longer going up. So this should have a round parenthesis. But I did not get 0 as an answer, so that means if I looked at the graph to see what's actually happening at 0, so change the window to maybe go from -1, and then you'll see that as it went through the origin, it was going up. So as it's passing through x equals 0, it is actually going up. So this one should have a square bracket. Okay, just one more. Find the equation of the tangent line. So that means that we need a point and we need the slope. The slope is going to come from the derivative. The point comes from, if you're given x equals pi over 4, then you can plug that in and find out what is tangent squared of pi over 4. And perhaps you already know that that equals 1. If not, you can use the calculator and say tangent. And when we write this squared right there, the calculator won't let me do that. I have to put the squared after. So pi divided by 4, and then put the parentheses, and then put the square, and it does equal 1. So in other words, the point that it's going through is pi over 4, comma 1. That is the point. Now find the slope. So this is much like it's exactly like this. So tangent squared means the whole tangent function is being squared. It's sort of awkward to write it this way, so this is just a shorthand for it. So when I do the derivative, I'll first need to do the power rule, so the 2 goes in front and you multiply. And then subtract 1 from that exponent, so it's going to be tangent raised to the 1 power. And then according to the chain rule, you need to take the derivative of the inside. And the derivative of tangent is secant squared. Now I need to plug in the pi over 4. So y prime, when I plug in pi over 4, will be 2 tangent of pi over 4, and then secant squared of pi over 4. And perhaps you know these values from the unit circle or something like that. If not, that's fine. You can go 2 tangent of pi over 4, And then for secant, I need to use 1 over cosine. So then times 1 divided by cosine, and then put the pi over 4, and then the squared. So it turns out that the slope is equal to 4. So now find the equation of the line that goes through this point and has this slope. So use the point slope formula. Y minus the y value of 1 equals the slope times x minus the x value, pi over 4. And then just simplify this answer. So distribute the 4, so that'll be 4x. Just so happens the 4's are going to cancel, so it just leaves minus pi. And then finally, just add 1 to both sides, so it's going to be 4x minus pi, add 1 to both sides, so plus 1.